Hello, this is David Morning, and I'll be giving you my presentation on Module 2 Water Filter Experiment. I did two setups in this experiment. Here's my first setup. I thought of this as the Earth's soil layers, and my first layer was the humus layer, which had the cheesecloth in it. And the cheesecloth kind of represents the roots of the Earth, kind of allowing the particles to stick to the cheesecloth, which was my hypothesis. I added a filter under the cheesecloth just to kind of grab some of those other materials, the dirt and the twigs and things like that, before moving into my topsoil, which had some charcoal in it. And the topsoil kind of has some minerals, so I thought charcoal might have been a good mineral for the water to help filtrate it. The subsoil, which has the sand to kind of represent some of the finer materials found in the soil layers, and ending up in my fragmented rock stage, which had the gravel, which kind of represents some of the harder materials you might see. And hopefully through this process, my dirty water will end up clean in the bedrock. So you can see the process here that I took. I poured number one, the dirty water, into the cheesecloth, and you can kind of see how my hypothesis was kind of correct in the second picture, where the particles of the dirty water kind of stuck to what would represent the roots of the earth with the cheesecloth. And then number three moved through the charcoal stage, which kind of had a sizzling sound to it, which I'll kind of talk a little bit about in a little bit, which would move to the sand. And number four, the sand would move into the gravel. You can already see how the water is a little bit clearer, and the number five picture is moving into the bedrock stage. And here's my end product, and you can kind of see how my water still had a little bit of a yellowish tint to it, which took me to my second setup. Round two, I added alum to my charcoal because after doing a little bit of research, I was kind of curious of why the charcoal was sizzling when I mixed it with the water. And I found that with the charcoal, it's acting as a filtration system to the water, and it's cleaning out the materials and the bacteria. And I also did a little bit of research of the alum and found that it kind of has some of the same aspects to it, where it's filtrating and cleaning the water, and separating the particles, the dirty particles, from the clean particles. So I decided to kind of do a mixture of the charcoal and alum to kind of see what would happen. And you can also see I added another filter underneath the charcoal and alum to kind of see if that would help get rid of that yellowish tint at the end. And I also was afraid, since the alum particles were pretty small, I didn't want them to fall through to the sand. So after completing this stage, you can see here's my new water. Doesn't nearly have as much of a yellowish tint to it as my first setup, which would kind of represent my hypothesis was maybe correct a little bit, in the sense that by adding the alum and adding another filter, it was able to clean my water a little bit better. Here's a side-by-side comparison. I started out with my dirty water, and you can kind of see a side-by-side comparison with experiment 1 and experiment 2. I do believe experiment 2, the water was a little bit more clear. So hopefully that alum and adding that other filter kind of helped filtrate the water a little bit better, and getting rid of those dirty particles. Some further questions I had is, I really wanted to see why it was that with the charcoal, the water started sizzling. So I just put some of that charcoal in another cup, put some water in it, and I just wanted to see what it looked like for myself, because I had a filter over top of it, so I wasn't really able to see it, but all I was able to do was just hear it. So when I poured the water in, it instantly started sizzling, and after doing my research, I just found that that's just the way it's trying to clean the water and help get rid of some of those particles, the dirty particles, which I thought was pretty interesting. Now, thinking of this as an inquiry continuum, this used the chart given to us through the D2L portal. This was a very learner self-directed activity. And you can see I have my circles here to kind of represent where in the spectrum each category would represent. The learner poses a question. I mean, we had very limited guidance in this inquiry process, whereas we had a couple different articles and videos, but the learner poses a question: how can you create a filtration system with the given materials in a way that helps clean the water by the end, so that way it's nice and clean for drinking. Number 2, the learner determines what constitutes evidence and collects it. And that's kind of relates to my 2 different setups. What would determine a setup that would help clean my water and not give it that yellowish tint in the end. You can see I did give one circle closer toward the teacher guided, but still towards the learner self-directed. But the learner guided in the process of formulating explanations from this evidence. We were given some things that would help us build our water filtration system, some kind of clues and hints through the process, which is good for any student through this process, to kind of give them some of those clues and hints if they're stuck, to kind of see where they can go from it if you just kind of give them a little piece of information. The learner independently examines other resources and forms the links. I was able to kind of make explanations from my different materials and see which materials will work best and where they would work best in the process, and also ending it where the learner communicates and justifies explanations. Well, we're doing that now in this presentation, and we're explaining our process and our setup and what worked best and what didn't work best and where we were able to end up at. So I hope you enjoyed my presentation. It was a lot of fun, and I hope you had a lot of fun with it as well. Thanks.